Hello everyone. In this video, I'll walk you through two project management dashboards I built using Power BI. First, we'll explore the portfolio dashboard, a high-level view that helps identify which projects are on track and which ones need immediate attention. Then we'll dive into a specific tech transfer project's EVM dashboard, where we break down earned value management metrics to monitor cost, schedule, and performance. Before moving to the dashboards, I created project plans in Excel, imported them into Power BI, cleaned and transformed the data, and built DAX measures to finally build the interactive dashboards. In the table view, you can see the project plans. This is for the tech transfer project, and this is for the portfolio. Within the tech transfer project, you can see the measures I created, for example, actual percentage progress, actual cost, budget at completion, CPI, and so on. So, also, data modeling is a critical step before proceeding to building dashboards. Now, let's begin with the portfolio dashboard, which gives us a high level view across all 15 projects. Right at the top, you can see quick snapshot, total number of projects, overall portfolio budget, and a risk level slicer. This slicer lets you instantly filter projects by risk, whether they are low, medium, or high. It's a powerful way to prioritize attention. For example, if you click on high, all other visuals will automatically get filtered and you can see the projects which are at high risk. Next, a donut chart gives us a clear visual of overall portfolio health. Each slice represents number of projects that are off track or on track or at risk. If you click on the off track section, all visuals update to highlight just those projects that need intervention. To the right, we have column chart and bar chart that categorize projects by department and by phase. It gives us a distribution of workload. For example, if you see high concentration of projects in the formulation department or within a particular phase, it can prompt a deeper discussion such as, do we have enough resources in that function, or are delays in this particular phase affecting multiple projects? So while it's not showing bottlenecks directly, it acts as a starting point for resourcing and timeline discussions, especially when paired with project risks and percentage complete data. Now here's a table showing all 15 projects, including their respective timelines, status, and completion percentages. What's particularly useful here are the icons beside each project ID. Green triangle means the project is on track. Red circle with a cross indicates the project is off track. These icons can be customized by conditional formatting. Now you have to just select this visual, go to format, and then cell elements. In the icons section, you can change the icons as you like and set your own rules here. I have also enabled data bars for percentage complete using the same menu under cell elements here. And this gives an immediate sense of progress. Okay, now finally, the budget versus expense chart at the bottom shows each project's planned and actual spend. Because the project names are long, I have used project IDs on the x-axis, but here's a neat trick. By adding project name or any other field to the tooltip field, you can simply hover over any bar to see which project it is and who's managing it. For example, if I hover over P001, I can see the project name, High Concentration Formulation Study, or P007, project name is Tech Transfer to GMP Facility. So when you click on the visual, in the build section, you will see tooltips and you can just drag any field in it. Once you hover over the visual, you'll see the details here. So in just one dashboard, we can assess project health and drill down into projects that need immediate attention. Before we dive into the detailed tech transfer project, there's one more feature I want to highlight on the portfolio page, and that's drill through navigation. If you're managing multiple projects, each with its own dedicated dashboard like this, instead of scrolling through tabs at the bottom, drill through feature allows you to jump directly from this portfolio overview to any project dashboard, just 2 clicks. For example, let's say if you want to take a closer look at P007 project, just right click on it, then click on drill through. This will instantly take you to the dedicated project page. And setting this drill through option is easy. Deselect all the visuals on the page and go to format, page information, and then drag the field you want to drill through from. In my case, it is project ID. So that is how you can navigate from one page to other if you want details of a particular project. Now let's dive deeper into the tech transfer project controls. At the top left is our date slicer. Pick any date and the metrics on this page recalculates to that point in time. So if you select say 22nd April, the metrics here will change. I built the dashboard considering 16 July as the current date. So I have selected 16 July here. One more information here is the metrics are driven by selected value in the formula. So this ensures that whatever date I select in the slicer, all the metrics are driven accordingly. Instead of selected value, you can have today in the formula, and as soon as you update your Excel and refresh the dashboard, you get real-time metrics as of today. So across the top, these cards display important EVM metrics. First one is a KPI card displaying earned value versus planned value. It shows as of July 16th, we plan to complete the work equivalent to $2.14 million of our budget, but we actually completed only $1.97 million worth of work. That means we have delivered less work than planned, which accounts to $180K, represented here in percentage. Um, you can change the percentage into value. Just go to format and then target label, distance to goal. Instead of percentage, if you select value, it will change to value here. So just to clarify here, I rounded the PV and EV values to 2 decimals. So when you do manual calculation, you get this variance as 170K, whereas Power BI does the calculation using precise numbers without rounding off and gives the exact final value, which is 180K. This insight can be used to implement necessary course actions. The next two cards, these are the simple card visuals and which show schedule and cost variance percentage calculated using simple DAX measures. So this one is cost variance, and the DAX measure is quite simple. And this one is for the schedule variance. Plus or minus sign in these cards is important here because minus sign indicates we are behind schedule and we are over budget. We can also display SPI and CPI instead of SV percentage and CV percentage. And you just have to drag CPI here instead of CV percentage. So next is the monthly planned versus actual progress bar chart. Each pair of bars shows how much work we plan to complete versus what we actually delivered month by month. You can drill up on this visual to roll those months into quarters. So in January, we plan to complete 93% of the work scheduled for that month, but we actually finished only 80% of it. This chart is month specific, not cumulative. So January bars only show tasks due in January. Even though it's now August, the bars for January only reflect how well we stuck to January's individual plan. Because some tasks that started in January run into February or later, the planned work for January is not 100%. It's only 93% of that work was supposed to finish in January. The remaining 7% rolls into the following months. The 80% actual in January means the work we planned to finish in January, which was 93%, we only actually completed 80% of it during this month. The remaining 13% of Jan's actual work just rolled into February or in next months. By reviewing these month by month gaps with stakeholders, we uncover root causes and turn those lessons into process improvements. Now, the line chart here is imported from the timesheet, this one, plotting actual man hours on the y-axis against entry dates, the timesheet entry dates on x-axis. The solid line shows what the team actually logged each period, whi- while this shaded band provides an approximate forecast, giving us the upper and lower bounds plus an average projection of upcoming work. Key requirement for this chart is your timesheet entries must be evenly spaced. For example, every 2 weeks or every 10 days, and so on. So the forecast algorithm can interpolate consistently. This data can be used for capacity planning. Now, directly below this bar chart, we have a decomposition tree that breaks down the total schedule delays by task. So, for example, we have total delay days, which is 69, and when you say when you decompose it based on task, it will highlight each task is delayed by how many days, and then decompose it further based on what the issue is and based on the action plan. So it is tied to a phase slicer. This visual is tied to a phase slicer here. All other visuals have been inactivated for phase slicer. Otherwise, all the visuals will get filtered only particularly for initiation or execution zones. So when you change it into initiation, you would see that the sum of delay days in the initiation stage are 26 days. So you can just decompose it further and pinpoint the root causes and highlight the corrective actions taken for each issue that cropped up. For example, when you decompose using task, there are 10 days of delay in communication plan development. And what was the issue? Misalignment on client CDMO communication protocols. And then you can further decompose into what was the action taken, what was the mitigation plan. This approach keeps stakeholders informed on past hiccups and also builds a rich lessons learned database. And I imported the data from issue log, which is here, issue log. Now coming to the the column chart, it simplifies the risk matrix. Each bar shows a risk ID on the x-axis and its risk score on the y-axis. This chart's data is pulled from the risk register. So instead of scrolling through dozens of rows in Excel, you instantly see which risks score highest and demand attention. I have added risk title in the tooltips. So simply hover over any bar to know the risk title. And if you need the full context, root causes, mitigation plans, or who's the owner, you can drill through on the risk ID to jump into a dedicated risk dashboard for deeper analysis. I did not build a risk dashboard, a comprehensive risk dashboard, but similar to how we did for project ID drill through, we can apply this similar drill through logic even for risks. Just click on this one and drill through, and you'll land into a specific risk dashboard. And if you need the full context, root causes, mitigation plans, the comprehensive risk dashboard would provide the same. Finally, the last one is a Gantt chart. Power BI does not have an inbuilt Gantt visual, so I imported it from an online source. Just expand the phases, for example, initiation, planning, execution, and so on. And the bars will give you the required information. For example, this uh, last task in planning, which was procurement and vendor selection, is 100% complete, and the start and end date of those tasks. Also, in the execution, you'll see the lighter bar, which is still in progress or not yet started, and the darker bars, the darker part of the bar indicates the completed part of the work. You can swap this with table visual as well, showing the same start and end date and percentage complete fields instead of Gantt chart. The axis you see on the top, it shows Gantt chart month-wise. You can also change it uh, in the format visual, the date type. Instead of month, you can select maybe week, and you'll have the Gantts based on the week. So that wraps up our walkthrough of portfolio and project dashboards. We have covered how to scan the full portfolio for high risk or off track projects, dive into EVM metrics to understand our project's cost and schedule health, and visualize resourcing trends and issues and risks and also timelines. With these real-time insights, we can make faster and data-driven decisions from high-level prioritization to task-level corrective actions. Thank you so much.